And so this is mechanical. In order for this to work, I have to have mechanical energy. And mechanical energy is energy of motion or position. So it's energy of motion. Energy of movement, motion has to be moving or position. So wherever it's at, then we put it in motion. So we're putting this thing in motion. Okay. So now let's move over to electrical energy. And so electrical is going to be a power outlet. So if I can draw a cord, okay, I'm going to try to do my best. You guys are better artists than I am. And then I'm going to show the prongs. And then this is the wire that comes through. Okay. Another electrical, well, we see this in our sky a lot of times, and that's the thunder. And this is the lightning, not the thunder, because that's sound. So this is, doesn't really look like lightning bolt. Okay, so electrical energy is energy from the movement of electrons through a conductor. Okay, so here you will have the copper wires. And then it meets the circuits in here, and of course you interact with the insulator. Okay? Alright, now let's go to light. So for light energy, we can have a light bulb. And remember, if you're in the classroom, you look up, there's the light bulbs. It helps you. Miss Young was telling me that her professor used to tell her that you're taking a test. If you look up, it's okay to look up. It's giving you inspiration. If you look down, it's in desperation. But if you look around, that means you're looking for information. So don't do that. Look at the light bulbs because it's getting you inspired, and making sure you keep your eyes on your own paper. So we have a light bulb. We also have the sun. And we also have candles. And remember the candle that we did with our plant during the carbon cycle. Okay? All right, and so the definition of light is energy that can, or light energy, is energy that can move through empty space in straight lines. And remember, light travels in straight lines. Okay? Let's look at thermal. Again, one of the things for thermal is also going to be our candlelight. I put that glowy there. So here we have the candlelight because it gives off heat. Okay. We also have the sun. And we also have a furnace, the old-fashioned furnace. So let me see if I can draw this. It's just like the little switch that you turn on the gas. heater. Label that heater. Y'all are much better drawers than myself. Okay, so thermal energy is energy of moving particles and that's the heat. Okay? And the last one is sound. Let me see if I can scoot this up. So we have sound energy. So an example of sound energy, let's say we have the bell. I'll do that for the sound. We also have the gong in the classroom. We also have a bell. So if you get stuck on sound energy, as some of you like to hit that gong, you know, it's vibration. So the sound energy is energy generated from vibrations and requires matter to travel through. Okay? All right, there you go. You can also look up some examples, some different examples, so that you have a better idea. So Google it and see what you find. Okay, what type of energy most closely matches each situation or example? So we're looking at mechanical for M, electrical energy, thermal energy, light, and S. And remember we did the melts and our... Okay, so we said it was mechanical. This is in the science doodles we have, and it's in your science journal. And this is the electrical. And this is light. This is thermal and sound. Okay, so let's look at this. Source of power in geothermal power plant. So this is from the ground. A source of power in geothermal power plants. That's thermal. T. Okay, type of power generator in geothermal power plant. So the type of power generator. So there has to be a generator. So what type of power generator is there? So they have to have, an electrical, because that's going to be running on some electricity, so you have non-renewable to help with the renewable. Source of power in a hydroelectric power plant. Okay? Well, we've talked about that, so if you've been in the research group, you know that that's going to be mechanical because it runs on a rotor, and the water has to turn it, powers that turbine inside. So that is going to be mechanical. Type of power generated by hydroelectric power plant. So the type goes to electrical. Energy used to spin a turbine in a generator. So if we look at it, that wind is turning it, so we need to have, that's going to be mechanical. Now the source of power in a photovoltaic cells, okay, so that's going to be light, so that gives you light energy. Okay, type of power used in Miss Benson when she sees a spider. Okay, so we can actually put somebody else's name, because, or, ooh, what do y'all hate? What kind of bugs do y'all hate? So here is Miss B is scared of spiders, which may mean more than one correct answer. So if you're scared of a bug, first thing you're going to do is jump, right? So that's going to be mechanical. The next thing you're going to do is scream, the bug! That's what my daughter does. And so that's sound energy. All right. Output energy of a fire alarm. Okay, in order for us to hear the fire alarm, that's sound energy. Okay. Alright, now let's move on to the next one. We're almost done. The International Space Station is the largest man-made object in space. There is more livable space than a six-bedroom house, covering over 38,000 feet. The solar panels are so large they could cover 8 basketball courts. All power aboard the station is supplied from these panels. 8 miles of wiring help get power to many different components of the space station. Space Cadet Atharva is in charge of preparing the meals. He uses an electric oven to heat the frozen meals and then cuts it into single portions for the astronauts. Okay, so which forms of energy were involved in preparing the meal? Okay, so he's in charge of preparing the meals. He uses the electric, so we know that we're going to have an electric someplace, right? So I'm going to circle electric for sure, electric here, electrical here, and that's not going to count because there's no electrical. So he's going to use an electrical oven to heat the frozen meals. Okay, so in order for an electric oven to work, you're going to have to turn a knob, right? So in order to turn the knob for an electric oven, because it just won't start itself when you close it up, you have to turn the knob, so that's mechanical. Okay, well, we have mechanical here, no mechanical here. So now, what heat is coming from heat? So what is that heat? It's thermal. Okay, it's not going to be sound where it says, I said heat, you got to heat. Doesn't do that. Okay, so the answer is A. All right, the next one. Which describes the complete transformation path to energy that took from the source of the heated meal. Okay, so what is the complete? So it didn't go from electrical to mechanical. That's not possible. So it could be, you go from, but we're talking about not from how it first started, but from the source to the heated meal. So the energy that it took from the source to the heated meal. Okay? Then it went from light to thermal. Okay? So it went from, oh, I'm so sorry about that. It wouldn't go from light to thermal, from light to heat. You missed something there, so that won't work. So you go from mechanical to light to heat. Because we have to forgot the electrical part. We go from the light to electrical to thermal, because it gives us the heat. So this would be the best answer. All right, Space Cadet Nanya's job is to care for the plants in the hydroponic garden. Special light bulbs are provided to facilitate photosynthesis. Now you've seen these. Some plants, when you keep indoors, they have to have a special lighting, and then they create their photosynthesis in order for them to stay alive. Describe in words how the energy needed for photosynthesis got to the plants. And so what happens is that the light energy from the sun converted to electrical energy by the solar panels. Because remember, they're all looking at your story up here. You got to go back to your story up here. It's operated by solar panels. That's an R. Okay, next you have